Okay, well, hello everyone. Welcome to this discovery session on Guarantee Your Engineering Major. My name is Bob Brennan. I'm a faculty member here at the Schulich School of Engineering. I'm also Vice Dean of the Schulich School of Engineering. So let's get started here and maybe, I hope you can see the slides. There we go, good. I just had some black there for a minute. So there are three engineering presentations today. There'll be some overlap in the information that you'll see. If you want to know more about engineering, please feel free to attend all of the discovery sessions that we're offering. So this particular discovery session covers more about the types of engineering majors and how we can guarantee your placement in your first choice of engineering major. Okay, so if you're interested in science and technology, an engineering degree really gives you the best of both worlds. Engineering combines both the natural sciences, so in other words, understanding the nature of the world around us, and the engineering sciences, so in other words, understanding how to apply science to solve, and mathematics to solve problems. As well, our programs provide substantial training and practice in engineering design. This is the creative aspect of engineering that really sets the engineering discipline apart from other STEM disciplines. At the Schulich School of Engineering, we've designed our first year program to give you a strong foundation in the natural sciences, engineering sciences, and engineering design, as well as exposure to the wide range of engineering disciplines that you can choose from at the end of first year. I'll provide some more information on the discipline shortly, but I'd like to just spend a little bit of time talking about engineering in general. But before I start, I'd like to point out that all of our engineering programs are accredited professional degree programs. So in other words, after graduating, you'll be academically qualified to become a licensed professional engineer in Canada. Next slide, please. So what is engineering? That's actually a pretty tough question to answer, given that when you look at the world around us, engineering is really everywhere, and almost everything you touch has some sort of involvement in engineering. But to give a few examples, as an engineer, you might be involved in, say, for example, designing a smaller, more powerful cell phone, or maybe a better diagnostic tool to detect cancer. You could see yourself involved in mapping traffic routes and designing better transit systems so we can reduce traffic jams, cut commute time for people, and also save energy. Engineers are also involved in protecting the environment by finding new ways of, for example, taking chemicals out of our water or building vehicles like aircraft, for example, that can be more fuel efficient. They're also concerned with protecting the public by ensuring bridges and buildings are created safely. For example, engineers save lives by finding ways to mass produce critical medications, as we've seen recently. They also innovate, creating software and tech devices that you can use to make your life easier. So more generally, engineers find solutions to problems that you probably didn't even realize were there, and as a result, make life better for people. So if you're looking for a way to make a difference in the world, engineering is definitely for you. So previously I talked a bit about the difference between science and engineering. To put this in more context, we could look at do a really simple exercise. So for example, if you look at your hand, I'm sure you probably already know a lot about how it works. You know that blood goes from your heart to your fingertips. The hand can feel temperature changes, skin heals after it's cut. But what about the mechanics of your hand, for example, how the joints work, the shape of the hand? Scientists in general focus on this part. So in other words, what they would look at is learning about how our hands work. So in general, they would make theory about how the world works or different aspects of the natural world. From an engineering perspective, we might take a different approach. So for example, we might see someone with a missing or a damaged hand, and the engineer would ask, well, how can we fix this? Can we create something that will give this person form and function of a hand and then improve their quality of life? So how can we take the knowledge that we've learned about how the hand works from science and build a new hand? How can we make life better for this person who has a missing or damaged hand? As engineers, we take science, scientific theories, and use that knowledge to create new things. So in other words, science is the understanding of the systems in the world. Engineering is building a system of the world. So maybe a little bit more on this. You might have been sitting in your classes and thought, well, for example, in the math class, I'm thinking, well, what is the point of this? I'm never going to use this stuff that I'm learning. Engineering, I think you'll find, is really a transition point here, where you take what you learned with math and with science, and you transform that into something tangible and real. For example, in math, one of the primary mathematical tools that we use is calculus. So this is something that you might have already taken, or you'll likely be taking next semester. What calculus does is it takes ordinary math and adds the element of time. What this allows us to do as engineers is create models of the natural world that we can then apply to solve engineering problems. So for example, engineers use this approach to model the physics of flight and then apply this knowledge to design sophisticated flight control systems for modern aircraft. And there are many more examples of this in the application of science and math to engineering problems. So anyway, that's some general information on engineering. And maybe if we jump to the next slide, I can sort of get into the details here and talk a little bit about our majors. So as mentioned earlier, at Schulich, we have a common first year. So in the common first year, you get that foundation that you need to then specialize in your discipline. And this ensures that you have this foundation in the disciplines, but also gives you a picture of how they fit together. And maybe more importantly for you, gives you the knowledge to hopefully make a really good choice about where you want to specialize for the last 3 or 4 years of your engineering degree. So these are the programs that we currently offer at the Schulich School of Engineering. And I'll just go through each of them in a little bit of maybe not a lot of detail, but just a kind of a high-level picture of what each is. So the first one here, biomedical engineering, it's a new program that we have. Biomedical engineering is really an intersection of medicine, engineering science, and other disciplines used to solve health challenges. It's really more than applying engineering to living organisms. Biomedical engineering includes new solutions to health challenges. Chemical engineering is about transforming raw materials into useful products. So, for example, you could be working with pharmaceuticals, healthcare, plastics, energy, various things like that. It's very broad based. It's a very general, broad-based form of engineering. Civil engineering is about helping the environment and building safe communities. So things like transit, bridges, buildings, water systems, etc. That would fall under civil engineering. Electrical engineering next is about creating new technologies through the manipulation of electricity or finding ways to better harness sustainable energy systems. You might not have heard of geomatics engineering. This is one of the fastest growing information sciences that we have. So if you think about GPS systems, global positioning systems that we have in our phones and our different devices in our cars, etc., that's geomatics engineering. So they look at the design of those systems, managing big data, the Internet of Things, and more. We have one of the, I think, probably the best geomatics programs in Canada here at the Schulich School of Engineering. Mechanical engineering is another fairly broad discipline. Encompasses everything from robotics to artificial joints to designing cutting edge vehicles. So if you like to design, make and build things, mechanical engineering might just be the discipline for you. And finally, software engineering is another area that's actually in fairly high demand right now. So companies right now are looking for the tech talent everywhere for people with knowledge of computer programming and software. So that's an area where you can pursue that. Lastly, what you can also explore here at the Schulich School of Engineering is a dual degree program. So these engineering majors are the undergraduate degree. So for example, you would graduate with a Bachelor of Science in Biomedical Engineering if you chose that. You could also choose to do a dual degree. So for example, you could do a Bachelor of Science in Biomedical plus a business degree as well and graduate that way. And we've structured the curriculum to help you do that if you're interested in having that broader experience. Okay, so let's jump forward to the next one and we'll talk about the minors. So these are the majors. And if we jump to the next slide. Here we go, great. So we have a long list here of minors. So you can, in second year or at the end of first year, you select a major program and that's your main discipline and that's what you get your engineering degree in. But you can also specialize in some other areas and have a minor degree that you take extra courses during your major degree to specialize in an area that you're interested in. So there's a big list of them here that are open in most programs. It depends on what you're in, whether you can select from all of these. But just to give some example, we have a biomedical engineering minor. So if you're not planning to do the major program, you could still have a biomedical flavor to your degree. Energy and environment further down the list is another one that's fairly broad. That say you're doing mechanical engineering and you want to focus on sustainable environmental solutions, you can add that to your degree as well. We are launching a couple new ones here. Aerospace is listed as new. I think we've already launched that one this year. So within mechanical, you could specialize in aerospace if that's something you're really interested in. We also have a digital engineering minor, which gives you that software and hardware digital flavor to your degree, artificial intelligence, big data, all that stuff that's really of great interest to companies now. We also have a new mechatronics minor as well. So that's kind of the intersection between mechanical engineering, electrical engineering, and software engineering. So think of things like robotics and unmanned aerial vehicles and things like that. Those are all mechatronic devices. So there's a lot of these. I won't go into all the details of that. If you're interested in looking at these, we have lots of information on these minors at our website. So just go to schulich.ucalgary.ca and you can see how that works. So at this point, I'm going to turn it over to Dr. Kim Johnson. She's our Associate Dean Teaching and Learning here at the Schulich School of Engineering, and likely someone you'd see in the classroom in the first year of engineering because she teaches first year and is one of our beloved first year teachers. So I'll turn it over to you, Kim.
Okay, thank you, Dr. Brennan. Lovely to meet everybody. Again, I'm the Associate Dean Teaching and Learning. I'm the Associate Dean Student Professional Development. So I'm really involved in things that happen inside the classroom and things that happen outside the classroom. So I'm here to talk a little bit again about our first year engineering. So we've had some questions around it. What we run at Schulich School of Engineering is a common core first year. So when you're admitted to engineering, all first year engineers are into the same common core. You actually select your major for second year. That first year, we'll talk a little bit about what the courses are, but it's really important to highlight the entire experience of that first year. There's a lot of opportunities inside the class. I'll talk about the courses and outside the classes. So we have a couple of spaces called the Makerspace and Zeta. When you actually get a tour around UCalgary campus, in the engineering building, you'll see a handful of rooms that all of the walls are actually glass, so you can look in and see them. We have 3D printers. We have robotics to play with and build your own robots. We have a textiles makerspace, so people can actually design clothing and costumes for some engineering events. I know it's used for that. We have a music makerspace with some instruments if you want to be playing some instruments as a downtime in between your classroom, in between your classes. If you want to be doing anything like digital editing of music or videos, we have spaces for you to be able to do that. A big part of why we have all of that space for you as first years is because of this idea that we have where we're here for you to develop you as a person. And part of that is your academics. And part of that is everything else that you do outside of your academics, everything that you want to play with your hands, everything you want to build, everything that you want to explore. So I do encourage you when you get an opportunity to come onto campus to take a look at those maker spaces and Zeta spaces that are extracurricular, just cool stuff to see. Oh, I didn't mention virtual reality. In the Zeta space too, we've got some virtual reality helmets that are kind of starting to, we've got to play around with those guys too. On to the next slide. So I mentioned that first year is Common Core. And then you go through a process in first year where you get to select your major. So Dr. Brennan spoke about the handful of majors that we have. He spoke about a variety of engineering minors that you can choose. And when you are in first year, you're actually going to get some exposure to all of those engineering disciplines. You get some science courses, you get some math courses, you get some chemical engineering courses, you get some viewing of mechanical engineering, a little bit of civil, you get some coding, you get electrical, you get software. You get to see a little bit of everything when you're in your first year. So we do want to expose you to the different disciplines. Some of you, if you're thinking about engineering, you might have an idea of what type of engineer you want to be, and that's fantastic. So if that stays the same throughout first year, we want you to know that you will be guaranteed to be placed into that program. This is something that is slightly different than what has happened over the years. So from other people, upper years, you may have heard about a competitive placement program that's based on ranking your GPAs, and that is no longer the case for us. So you now have a guaranteed program placement. We want each and every one of our first year students to be doing the type of engineering that they want to do. That's it. That's the fundamentals of the program placement program. But what I do want to encourage students when first years come is, even if you think you know where you want to go, come with an open mind. First year university, especially, and all of university, is about an exploration around what's interesting to you, around opening your eyes to what other types of engineers can do, what other type of people might influence you, what other types of passions might be awoken in you. So really what we do here at Schulich School of Engineering is the best of both worlds, where you get that whole first year to explore, and you are guaranteed to be placed in your program of choice. So we'll flip on to the next slide. You do have some requirements for program placement, but again, I want to highlight that it is not competitive. We have spots, and we will create spots for each and every student that wants to be in the program who successfully completes first year. So what you do need to do is complete your first year. First year has 10 technical courses. You can also take an 11th course, which is a complementary studies course. The 10 first year technical courses, again, it's coming, I'll tell you what they are. But what you need to do to get your first choice program placement guaranteed is to complete all 10 of those first year technical courses and maintain good standing. So good standing is above a 2.0 GPA. And you do need to pass all of your courses with a C- or better. So that's all. If you do that, you get your first choice. It is attainable, it is simple, and it is guaranteed. We will create the spots for you. The reason that we made this change is, number one, because we care. Because we at the university, where you'll hear the term a lot when you come here around campus community. The campus community includes the faculty members and the staff members and the students. We really like to foster an environment where There isn't as much of a hierarchy. It's not that I know what's going on and you don't know what's going on. You're here to learn and grow as a person, and we're here as a community to support you. We had heard over the years that a competitive placement process was very, very stressful and not a pleasant process to go through. So because we care and because we listen, we have changed this to just this guaranteed program placement. We want you to be doing what you want to do, and you want to be doing what you want to do. So that's how we do our program placement. On to the next slide. So these are the courses. The numbers probably don't mean anything to you right now, so I will tell you a little bit about what they are. You will see ENGG courses. That probably makes sense to you that those are engineering courses. There is not actually two Gs in engineering. So the reason there's a second G in our first year engineering courses is the second G stands for general. So those are general engineering courses. Eng 200 is your first year design course. So you get a big course where you work in teams to design problems. This one happens in the winter term. So you will have taken electric circuits, you will have taken programming, and then you get to apply some of those engineering skills in a design project. Mostly it ends up being a lot of fun. It's a pretty challenging course, but it's really a lot of fun. Eng 201 is the course that I teach. So that's a first year fluids course. It's a really fundamental prerequisite for chemical and mechanical engineering. We talk about the phase behavior of gases, liquids, and solids. It's the fundamentals of thermodynamics. It's the fundamentals of separations. It's the fundamentals of how mechanical engineers make power plants work. It's the fundamentals of how chemical engineers create processes to isolate chemicals. It's the fundamentals of how distilleries work to create alcohol. So that's what Eng 201 is. Eng 202 is statics. It's again a really basic fundamentals for civil engineering and mechanical engineering. It's about force balances and structures. So a lot of analyzing how structures are held up. You know, we always hear engineers build bridges. To build a bridge, if you go look at a bridge, you're going to see things like cross trusses and curved trusses. So you need to do the analysis on how those materials hold forces to be able to design anything. So that's the fundamentals in 202. Eng 225 is electric circuits. So you get a lot of opportunities to play with breadboards, to build circuits, to play with oscilloscopes, to dig into signals and signals processing. So it's really a fundamental of electrical engineering. ENDG, that one stands for digital engineering. Digital engineering 233. So Dr. Brennan mentioned that we now have a digital minor. As the world becomes increasingly digital, it doesn't matter what discipline of engineering you have. We're all starting to get this feel like digital engineering is a key part of absolutely everything. So that may be coding, that may be some software development. This one is a first year course where you learn Python. So you learn a coding language, you learn some of the fundamentals of coding. So those are your 5 engineering first year courses. And then you've got a couple of math courses and a couple of physics courses. And if you are counting, you will notice that this list adds up to 9 because we are actually missing a third math course in there. Math 211, you have linear algebra. You have Math 275, which is Calculus 1. We actually also have a Math 277, which is Calculus 2. We're missing the second calculus course on there. You've got a physics course and you've got a chemistry course. So that is your 10 technical courses in first year. Over to the next slide. So a little bit about how first year registration works. We use a block system. So first year engineering is a fair number of people. This year we're working with about 1,000 students, so that's a fair number of people. Registration, if you're in a different program, if you go to a program other than engineering, you get a bit more flexibility. But in engineering, we know what it is that you want to take. So we actually register you. When you're admitted, you can basically, when you accept your admittance or when you accept your letter of admission, we register you in the blocks. So you don't have to go through a lot of those hurdles, which is really quite nice. How we deliver first year is based on actually pedagogy. Here's a word, whether or not you're familiar with the word pedagogy, but pedagogy is the science of exploring how people learn. So there are people who do a lot of research into your brains specifically and how your brains are going to best learn the material. So we've designed first year around what people who study people have learned about how people's brains learn. And so what we're doing is a blended learning, a combination of some virtual content and some in-person hands-on content. So some of the content goes online. Those are sort of your basic lecture videos, the material that you're going to want to look at once and then reference again later. Some people want to watch it slowly. Some people want to watch it quickly. Some people like learning in the evenings. Some people like learning in the mornings. So you've got your course material accessible for you whenever you want, however you want. And then when we're in person, you're in a cohort, in a learning cohort of about 100 students, meeting with your instructors in an experiential learning type of environment. So the actual in-person time includes things like classroom demos, hands-on labs where you're building things, working with teams on your projects, working on the hard problems. So sort of getting some assistance working through the challenging problems that we typically see in first year. So your first year, again, a really big combination of virtual course material available all the time and meaningful hands-on experiential learning when you're in the classroom. Over to the next slide. There's a lot of other things that happen in first year too. You are a variety. We've got 99 people in this room. And I can guarantee you that if I were to ask you what you like to do outside of engineering classes, I would get a lot of different answers. Some of you would actually be interested in the same thing, which is really exciting. You might get to meet somebody else in engineering who's into the same sports that you're into, or who is into the same games that you're into, or is into the same types of music that you're into, who wants to make films with you, wants to make clothing with you, wants to build robots with you, right? Everybody's got a different set of interests. And so what we really like to do is foster that. We like to invite you in with all of your interests and passions. Therefore, what we have is some programming around how we actually support you and your differences. One of these is the student athletics program. So if you are a student athlete, we can actually modify your programming for you in first year. One of these is tutoring support. So everyone's brains work a little bit different. Some people will find that when you come in, your coding course is the easiest thing in the world for you, and your fluids course really confuses you. So we've got supports to help you along with that. We really also like to offer the first year with a variety of learning styles and experiences. So even when I talked about this blended learning, we really try and deliver the material in a handful of different ways because people are diverse. And, you've probably heard of different learning styles where some of us are auditory and some of us like reading and some of us like hands-on. And, more and more we're learning that that's a little bit simplistic. You might lean more towards one or the other, but everybody's actually a combination of both. So what we really do in first year is try and give you a big variety of experiences, which mean in the classroom and out of the classroom, such that all of your different learning styles are actually stimulated while you're here. Over to the next one. We also have international experiences. Obviously, in this world, in this last year or so, these have been a little bit challenging, but we're hoping to start bringing all of these guys back. International experience is a really, really key part of learning and growing and developing who you are as a person. So we have a wide variety of big international experiences and little international experiences. In both your fall term and your winter term at UCalgary, we have a full week break. They used to be called reading breaks. They're not called reading breaks anymore. We just call them fall break and winter break. But in those fall breaks and winter breaks, the 1 week, we actually offer a variety of international experiences. So you can sign up to go for a week with, kind of 20 of your classmates and a faculty member and a staff member to go have an international experience, learning experience somewhere. We've done things like building houses somewhere else, going on tours of engineering facilities, process plants, water processing plants, learning experiences somewhere in the world. So those are opportunities. We also have group study programs. So you can actually apply to go take spring, summer courses in other countries. We've got some Germany, Spain, and Switzerland programs. We also have funding for these. So they don't end up being entirely free, but they end up being very, very heavily subsidized. So if you're interested in exploring the world, it's a fantastic subsidized way to do it. It ends up being very, very affordable for students. Over to the next slide. And speaking of affordability, I'm going to finish off with highlighting a wide variety of scholarships and awards. We know that university is a financial stressor for many, many people. This is a list of some of the scholarships and awards that are available. There are some scholarships awards available specifically for engineering students. When you apply to engineering, you will be automatically considered for some of them. So it's just based on your grades. So your name will automatically be in the pool for some of our awards. Some of them actually require a separate application. So you will fill out your application to engineering, and you will fill out a separate application for scholarships. Those are due on December 1st. They're definitely worth it. So make sure to find those and make sure to put your name in for those. There are also scholarships available from UCalgary in general, outside of engineering. And the other one that we really encourage you to think about is that there's lots of scholarships available outside even of the of the University of Calgary official channels. A lot of our students report things like their parents' companies actually have scholarship opportunities, or other places like that, maybe a place that you've worked somewhere. So it's definitely a worthwhile thing to do some looking into, maybe even Googling or talking to people and seeing what's available out there. Well worth the effort of application. And with that, we are pretty much wrapped up. Here is an email and an opportunity. We do encourage you to reach out and ask some questions and talk to us and get your questions answered. So thank you.
Thank you very much. I was reviewing the chat, and I believe this was a very wonderful and informative sessions, and a lot of our questions were answered throughout the session. So if we do have some outlining questions, you can go ahead and put them in the Q&A right now. We can try to get to them, but reminder, this will be recorded and viewable at a later date, so you can watch it through our YouTube or on our website. So if you want to spread the word, if you miss something, you're welcome to go back and review it at any time. We also are available. Some of us are our advisors, and our career advisors are available in our chat through our booth. So if you have an outlining question outside of this, please join us in our chat. And the next session that is going to be held at 1 o'clock is regarding our careers. So you had some questions about that. So we'd love to see you then. So I'm just watching the Q&A now to see if there's any unanswered questions. And we'll just review it. Nothing was outstanding throughout the question. You guys answered everything that came in. So we'll just keep watching the Q&A here for a few minutes to see if there's anything outstanding.
I might.
Oh, sorry. Go ahead. Oh, sorry. Go ahead. Sorry.
There are lots of questions about the minors, which is pretty cool that folks are interested. I'm thinking now that there's something that I didn't really highlight. The majors are a guaranteed placement, but the minors actually still have a finite number of seats. So the minor placement is still actually competitive. I saw that we had the question, does it extend your undergrad degree by 1 year? The minors don't, and it was answered. They don't actually add another year, but most of those minors add a couple of courses. So if you're going to take an engineering minor, you'll find that your your workload is a little bit higher than what it would have been compared to some of your classmates, but they typically add 2 or 3 courses over the course of your degree. So still doable, but you've got a few more terms where you're going to have to be taking 6 courses instead of 5.
And I think a thing to note as well is there is no minors in your first year. So this will be, you'll be offered the minor application when appropriate. Not all minors are a second year minor. Some are third and fourth year minors. I see a couple admissions questions, so I'll grab those right now. So high school admissions, we're recommending you go in the high 80s to the 90s. However, we always want you to take the opportunity to apply to us if you want engineering. So always apply if you wish. It is a competitive faculty, so it's hard for us to set that number because it just depends who you're working and competing with to get in to engineering. So just strive for as high as you can, as we'd love to see you all engineers come in. So if you're transferring from another post-secondary, again, it's a competitive GPA. So again, we're looking into the 3s, if that makes sense to you guys. And typically upper year placements are not, meaning directly into a major, as those ENGG courses that were mentioned are specifically to U of C, and you do need to have those to move on to your majors. So usually you'll come into our first year with possibly some transfer credit with some of the general courses, but you do start again in the first year and then are placed in your major into your second, just like everybody else. So again, I'll keep watching. Those were the questions regarding admissions that kind of were in there. I did put a link in about scholarships, but check out our Schulich website. Also, those are Schulich specific scholarships. You can also look at the university finance scholarship awards, as there's multitude out there that may be applicable to you. I'll just keep looking. There's a question about deferred admissions. Engineering doesn't do deferred admissions. So if you don't think you're going to be able to join us for the year that you've been admitted, then you'll just be reapplying for the following year and competitive to that year. So we don't do deferred, and typically, and the majority of the time, we are only a fall acceptance. Calculus, again, a lot of admission questions, so I'll just keep going. Calculus or Math 31 or equivalent is required unless it is not offered. If that is the case, admissions will review your file and give you the options available to you. So if you have any admissions questions, just note that we don't review transcripts at engineering. That goes to the admissions booth. So take a look at them and ask the questions for any type of admissions that you have. There's a question about how many students we admit in our first year. Do you guys want to kind of review that and our block system?
You want to do it, Bob?
Sure, I can start and jump in if you like, Kim. So this year we admitted almost, I think, 1,000 students first year. So we have a block system that's set up. So we have 10 blocks of 100 students. And the way that works, it fits in what Kim was describing earlier with first year, that basically we have 5 blocks who will do in-person type active learning type work in the mornings, and then have the afternoons more free for the online lectures and working on homework and all those sorts of things. And the other 5 blocks, it flips. So they would do their in-person active learning stuff in the afternoon. So I think that's how we're doing it. Do you have anything to add, Kim, about that?
No, that sounds great. I might answer, I see 2 questions that are kind of similar. Do you have to take 6 courses in some semesters to complete engineering? And is it an option to take lighter course load with spring classes? Can I answer them together and say basically yes? There are a lot of years where to stay on track with the program, you would be taking 11 courses in 1 year. So, as a default, you could do 5 courses in 1 term and 6 courses in the next term. Some of our students do choose to take a course or 2 in the spring summer course to spread that out.
One thing, this might sound really simple, but it might be good to mention. We're talking about GPA, grade point average, and I know when I started as an undergraduate, I didn't know exactly what the system was. So we talk about a 2.0 GPA over 10 courses to have guaranteed placement. That's really just based on the letter grade. So for example, a letter grade of A is a 4.0 and a C is a 2.0. So what we do is we look at all of your courses and basically calculate the GPA based on your letter grades. So if every single course you took, you get a C in those courses, you would get a 2.0 GPA. So I don't know if that helps.
Again, just going through, I think we've answered a lot of our questions. So we are coming to the end of our session. So if there is any more dying needs, please contact us through the chat. We've got advisors there as well, along with professors, program directors. So you can join us in our booth, in our chat, if you have some more dying questions. And the 1 o'clock session is regarding our career centers. So intern co-op opportunities. So I guess any more last final words, and we can end the session when you're ready.
I'm going to jump in with one. I see a question from Rom. What major would you suggest for someone who's looking to get into a nuclear engineering career? I know we have graduates from both chemical engineering and mechanical engineering that have gone that direction. I'm sure actually electrical engineering, because there's a bunch of power generation processes that are involved in that as well. But yeah, chemical engineering, mechanical engineering. Dr. Brennan, I don't know if you've got more to add on that.
Oh, that sounds good to me. Yeah, and I guess it depends on the nature of what you're doing in that industry, because you could have a few different disciplines involved. For example, electrical engineering. There, I don't know if you said that, Cameron, out, but certainly you're generating electrical power, so I imagine electrical engineers would be involved too.
Ria's got a good question too. Do some courses come before others, Eng 200 before Eng 21, etc.? Yes, in first year, there are a couple that come in sequence. And so there are some courses in your fall term that you have to pass in order to take the course in your winter term. Some of those are, for instance, math. You need your math calculus 1 before you go to your math calculus 2. You need your a couple of the maths in the fall term before you take your physics in the winter term. So yes, there are some sequences like that.
Okay, thank you very much. We're going to end this session. So thank you very much for your time. Any more questions, please join our chat or join our 1 o'clock session on the career. Thank you very much, everybody. Have a wonderful day.